this academic hour. So today's topic is my dosimetric verification of reference air Kerma rate for HDR afterloading units with iridium-192 and cobalt-60 photon sources. Comparison of different international protocols. Here is my outline. Brachytherapy, also named as chemotherapy or radium therapy. It is treatment of cancer by keeping the source in proximity of the tumor. It has distinct place in the radiotherapy of malignant tumors, especially for the intracavitary treatment of gynecological cancer and interstitial treatment for prostate, breast, and head neck cancer. A high dose can be delivered locally to the tumor with rapid dose follow-up in the surrounding tissue. It generally high confirmed dose distribution in the target volume. The word brachytherapy originates from the Greek word brachus, meaning the short. The radium was discovered in Paris in 1898 by Mary and Pierre Curie, and within a few years, in the first successful brachytherapy treatment was reported. And so brachytherapy source. The three types of brachytherapy source according to the emitting. The first of is the photon sources. This emits gamma ray through the gamma decay and possibility characteristic X-ray through the electron capture and internal conversion, such as cobalt-60, cesium-137, iridium-192, etc. And beta source emits the electron following beta source decay, strontium and yttrium-90. And neutron source also emits neutron following the spontaneous nuclear fusion. And the characteristic common radionuclide used in brachytherapy source: cobalt-60, cesium-137, gold-198, iridium, iodine, and polonium. Now, in my study, I used two types of source. One is the cobalt-60, where the main average dose is 1.25 MeV, and half-life is approximately 5 years, 5.26 years. And another is the iridium-192, where the average photon energy is 0.38 MeV, and half-life is 73.8 days. Actually, cobalt-60 source is useful for the developing countries such as Bangladesh, India, or Nepal, or Pakistan as South Asian countries. And types of brachytherapy. The brachytherapy types according to the implants: intracavity, interstitial, surface plaque, intraluminal, intraoperative, also known as the IORT, and intravascular. So what is the intracavitary brachytherapy? Where the source are placed into the body cavity, and interstitial source are implanted into the tumor volume. And surface plaque. Surface are loaded into the plaque, which is brought into the contact with the skin surface lesion. As like interluminal source are inserted into the lumen, and intraoperative is that different from others. Source are brought surgical into or near the tumor volume. And another one is the intravascular. Source are brought intravascularly into a lesion or near lesion. So according to the treatment definition, brachytherapy also two types: temporary implant and the permanent implant. In temporary implant, dose is delivered over a period of time that is short in comparison with the half-life of the source. Source are removed when the prescribed dose has been reached. In temporary implants, cesium-137, iridium-192, cobalt-60, and radium-226 are using. And permanent implants, where the dose is delivered over the lifetime of the sources. The source undergo complete radioactive decay. Where is the gold-198, iodine-125 are used. And according to the source loading, also two types of the brachytherapy, and one is the hot loading and another one is the after loading. Hot loading. The applicator is preloaded and contains radioactive source at time of the placement into the patient. And after loading, the applicator is placed first into the patient and radioactive source are loaded later, either its hand or machines. Nowadays are most commonly used in the afterloading brachytherapy system. If we consider according to dose rate, brachytherapy is also divided three types on low dose rate, medium dose rate, and high dose rate. Further, in low dose rate, the 0.4 to 2 gray per hour is the dose rate, and medium dose rate 2 to 12 gray per hour, and whereas the high dose rate greater than 12 gray per hour. Source specification. I introduced I will short brief on the source specification. Each brachy source has a specified source strength that is used to calculate dose rate. Source strength can be studied in terms of one of several interrelated physical quantities such as radium equivalent mass, apparent activity, air Kerma rate, air Kerma strength, and exposure rate. Radium equivalent mass. Radium was predominant source in brachy in early days. So source strength was defined by mass of radium. For non-radium source, strength can be specified by radium equivalent mass. The relation between the milligram radium of equivalent and its activity is 1 milligram radium equivalent equal to 1 millicurie of radium. Exposure rate constant. The exposure rate constants defined as exposure at unit distance from the point source of activity. Its defense as the source should be a bare point source. The photon fluence is neither attenuated nor scattered in the distance. Air Kerma rate constants. In this form, this relation, air Kerma rate constants, relation between the exposure, air Kerma, and exposure rate constant. The unit is microgram meter square per curie per hour. Reference air Kerma rate. The quantity of reference air Kerma rate is recommended by the ICRU 38 and ICRU 58. The reference air Kerma rate is defined as the Kerma rate to air in air at reference distance of 1 meter, corrected for air attenuation and scattering. And another last one is the apparent activity. Basically, the source is not bare point source. It is encapsulated by filter material, which is introduced and attenuations. The reduction in air Kerma rate happens to compensate this attenuation effect. Apparent activity is introduced. If the source is calibrated under air Kerma rate conditions, the source distance may be specified as apparent activity or effective activity. And as the air Kerma strength, in 1987, the American Association of Physicists in Medicine, AAPM, in their report number 21 in task group 32, introduced the idea for the specification of brachytherapy source in terms of strength instead of the exposure rate. The product of air Kerma rate in free space and square of the distance of the calibration point from the source center is called the air Kerma strength. So what are the importance of calibration? Calibration is very important step in physical aspect in brachytherapy. The calculation of dose to a patient depends on the accurate source calibration. The uniform precision of the radiation from the brachytherapy source can be greatly affected by the distribution and encapsulations, so that source need to be measured. Usually a certificate is provided with the purchased radioactive source that describe the source and its activity. There are generally three different methods of measuring the air current rate based source strength. Standardization of brachytherapy source, as like external beam therapy measurement, brachytherapy measurement should also be traceable to the primary standardization lab. In brachy, sources are standardized in terms of reference air current rate or air current strength. Based on the source strength, three methods are developed: measurement using air setup with ion chamber, measurement using well-type chamber, and measurement using solid phantom of well-defined geometry. So, what are the objectives in this study? To determine the reference air current rate in well-type ionization chamber, free in air with cylindrical chamber, using IAEA Tech Doc 1274, WFPM TG41, and DIN 68092 protocol. Also determine the reference air current rate in solid phantom, which is also known as the Krieger phantom measurement, using DIN 68092 protocol. And finally, compare calibration results among different protocol and different methods. So now I explain the reference air current rate measurement using the well type of ionization chamber. I used cobalt 60 and iridium 192 source in different hospitals. One is the Varian Gamma Plus, and another is the Vivek multi-source. The high dose rate well type chamber is placed in the treatment room and connected to the electrometer. A transfer tube has been connected to adapter of well chamber. The source travel directly inside the adapter without an applicator. The transfer tube is inserted into closely fitting the thin walled aluminum tube on the axis until the end of the touches the bottom. Measurement have been done in minimum scatter environment, thus the chamber should at least be 1 meter from any wall or floor. And setup measurement have been done within few minutes. Then the plan is imported to TDU. The well-type re-entered chamber used for the present study in hermetically sealed and contains pure argon as the field gas at a pressure of 23 pascal, and the chamber has a diameter of 17 centimeter and 31.3 centimeter height. And another one is the 14 centimeter, 17 centimeter, and height was the 30. This is equation according to the IEA and DIN protocol. The mostly same parameter was same, and difference in WPM protocol. Where is the air current rate in denoted at the SK air current strength, and in IEA and DIN protocol which denotes reference air current rate as KR. Reference air current also measured in solid phantom. The PMA phantoms is the diameter of 20 centimeter and the height is the 12 centimeter. Measurement were performed using 0.6 centimeter chamber, ionization chamber. The ionization chamber placed in the 4 holes, which is the angle from the center of the source, 0 degree, 90 degree, and 180 degree, and another is the 270 degree. For each hole, height average electrometer reading was taken and the mean of the values determined for all the holes. The source was made to dwell in nylon catheter position positioned centrally in the phantom. This is the DIN protocols, whereas the reference AKR merit is denotes KA100A. And hence the measurement in air camera in air. In calibration procedure, the air camera has been measured at several distance from the center of the active core of the source and reference point of the ionization chamber in specially designed jig. Room and geometrical condition is adequate to enable position of the air set up such that there is minimum of 1 meter distance from the room floor walls ionization chamber avoid the scattering dose. For SDR source calibrations, the measurement distance is selected around the optimum distance. Actually, it's the distance between the 10 centimeter to 40 centimeter. And in my study, I measured at a 15 centimeter distance is taken to determine the air camera rate. For SDR sources, ionization chamber with volumes greater than 0.5 centimeter cube up to 1 centimeter cube volume. And the ionization chamber must be greater than 0.5 because to avoid the too small chamber volume may give problem due to the lack of the signal. The jig are made of non-scattering and low jet materials of the 2 vertical stands and 2 parallel aligned horizontal wooden bars. In these 2 vertical holders, one is for placement of the source applicator and another one is the ionization chamber. 2 horizontal wooden bars have been movable on floor. 2 vertical holders are mechanically fixed with the 2 horizontal bars. And measurement in free and air, the IEA protocol, according to the APM protocol, and according to the DIN protocol. So comparison of protocols for measurements. Mostly methods are well accepted for the 3 methods without solid phantom measurement. In IEA take the 1274 and APM TG41. It's only established in DIN 68092 protocol. So, well-tap chamber measurements, the calculated value and measured value also there. The deviation of well chamber measurements, APM protocol, EDM 190 source has the measured value was the 31.74 and the current air camera rate according to the certificate or the TCP 31.9. Whereas the deviation only 0.5%. In cobalt 60, whereas the minus 0.42. And IEA and DIN protocols according to them, the iridium 192, the deviation was 0.31% and cobalt 60, where is the minus 1.65. In solid phantom measurements, the also deviation in iridium 192 is greater than the well-tap chamber. In iridium 192, where is the deviation 1.22% and cobalt 60 1.75%. And measurement in clean air, according to the IF protocols, iridium 192 where the measured value is 26.632 milligray per hour, and where is the certificate value was the 26.90, where is the deviation 0.99%. In cobalt 60, where is the minus 2.18%, and according to the DIN protocols, where is the deviation in iridium 192 sources 1.41 and cobalt 60 minus 2.18. And APM protocol, the for iridium 192 source deviation was 1.74. So in the summary of the deviation in different methods and protocols, where is the in chart, you've seen that the solid phantom only for DGMT, whereas the deviation is the mostly similar 1.2 and as the 1.75, the below that 2%, and for air in free in air measurement according to the IEA DIN and WAPM, this color is the iridium 182, the upper portion, and lower portion is the cobalt 60. Lower portion is because is the given is measured value was minus 2.18% deviation measured value between the certificate value, and well type chamber mostly similar for 3 methods and 2 sources. 0.31 where is the minus 1.65 and 0.5 where is the minus 0.05 is mostly similar in the APM protocol, and DIN protocol is the DIN protocol and the IA protocol is measurement was same, both of the same. So the calibration results of different protocols for different methods are acceptable limit within the 5% which are recommended. And APM task group 40 recommended that if the variation measurements disagree with the manufacturer value by more than 3%, the disagreement should be investigated. Discrepancy greater than 5% should be reported to the manufacturer. As far as the accurate measuring equipment, the well chamber is simple and reproducible at the clinical level. Free in air measurements is difficult and cost of lot of time is therefore not useful for the clinical routine. But solid phantom methods can be recommended as quick check and quality control purposes. Air Kerma rate measurements for cobalt 60 HDR sources using the existing protocols are possible with the accuracy sufficient to verify the source calibration as provided by the source certificate. So now I conclude my this lecture. Whereas in conclusion, while the methods of calibration of HDR brachytherapy source discussed in the study are effective to be used for routine calibration purposes with acceptable accuracy, well chamber and Temple chamber based the dosimetry system both are the fast and reliable tools for iridium 192 sources. Source strength for cobalt 60 source can be measured with a comparable uncertainty using the same instrument with the same dosimetry protocols as used for the more common iridium 192 source. A medical physicist is responsible for quality assurance program to maintain the system within its acceptable performance standard which grant in the treatment in accordance with the purpose. Checking the source parameter is one of the most important part of the quality control system in brachytherapy facilities. The risk of inadequate radiation treatment can be minimized through the systematic execution of a comprehensive quality assurance program. So, in my study, lots of helps me, and now I acknowledge to this person as the Professor Dr. Ghulam Abul Zakaria sir, and Professor Dr. Hasin Anupama Azari ma'am, and MD Arnold Islam, the medical physicist, and Mr. Safai Zaman, also medical physicist, and Saria Prince Sara, also medical physicist. Thank you.
Thank you for your nice presentation. I would like audience to ask questions if they have. They can unmute themselves and they can ask questions.
Is there any questions from audience?
So I have one question.
Sure, please.
Its cobalt 60 brachy source is also available in your hospital, or you done in any other center?
In our hospital, cobalt 60 source available.
Okay. There is a question in the chat box. At what distance are the ranges of low dose rate brachy HDR and medium dose rate defined?
This purpose.
Yeah.
For which?
You can check the chat box for the question here. At what distance are the ranges of LDR, HDR, and MDR defined?
For these three measurements, the one is the well depth chamber, another is the clean air, and another is the solid phantom. In this, according to the protocols in DGMP 68092 protocol and TG 41 and is the IATEC 1274, they are mentioned minimum 1 meter distance from the source, from the any wall, floor, and due to the scattering, and avoid the attenuation dose, and also uncertainties avoidance.
Okay, I have a question about the cobalt 60 source.
Yeah.
Are there any additional precautions for the cobalt 60 brachy source as compared to iridium 192?
As like a similar, the in our hospital, cobalt 60 bunker is the totally separate from the from other ones, and is also well shielded rooms. In periodically after 3 months, we survey, and we found that dose is so low. It was background dose 0.2, 0.1, 0.3 as like as the microgray per meter per hour.
Okay. Okay. Thank you very much, Mr. Jobairul Islam. Thank you for your time, and thank you all the participants. We hope that this lecture is quite fruitful for all of us. So we will be joining again next week. We have another session. So flyer will be shared soon. Thank you very much, and we'll be signing off right now.
Thank you, Mr. Asad, and thanks to all participants. And I again apologize for the delay. Actually, I left a pause. Happened some problem due that I joined lately. Thanks again for inviting me and conducting this such a nice program. Thank you.